So all of the Jovian planets have magnetic fields. Jupiter's magnetic field is 14 times stronger at the surface, so that's the cloud layer of Jupiter, than the magnetic field that we experience on the surface of the Earth. This intense magnetic field actually creates a magnetosphere that is the largest in the solar system. From what we can tell, the magnetosphere actually stretches from 2 to 3 AU beyond Jupiter. Hey, remember, an AU is an astronomical unit, the average distance between the Earth and the Sun. In other words, this thing is gigantic. Many of Jupiter's moons are actually going to be within this magnetosphere. Now, we do see that charged particles become trapped within the magnetosphere, similar to how it is that charged particles become trapped within the Van Allen belts of the Earth. However, because of the intensity of the magnetic field and how fast it is rotating, these things actually get spread along a relatively thin sheet, which you can see here. That's what we refer to as the current sheet, but it's a similar idea to the Van Allen belts. We can look at how fast, or the emission of these charged particles trapped within Jupiter's magnetic field, to help us understand the rotation of the interior of Jupiter. So what we see are the cloud tops and how the cloud tops move, but as we look at the magnetic field, it's tied to what's happening in the interior of Jupiter. And we actually see that the interior of Jupiter must be rotating slightly slower than the visible cloud tops that we actually see. Now, all of the Jovian planets have strong magnetic fields. It is not just Jupiter. For Saturn and for Jupiter, the magnetic field is likely produced through the liquid metallic hydrogen surrounding their core. Of note, we actually created liquid metallic hydrogen on the Earth for the first time just recently. So, although it has been predicted theoretically, we now know that it does actually exist. For Uranus and Neptune, the magnetic fields are likely caused by the water-ammonia mixture. Okay, so that layer that has a mixture of ammonia, water, and methane. Okay, this is going to be a very good conductor of electricity. Now, when we look at the magnetic fields for Uranus and Neptune, we actually see that they're weird compared to the other planets that have strong magnetic fields. So of all of the terrestrial planets, the Earth has the strongest magnetic field. And when we look at it, we see two things. One, the spin axis and the magnetic field are relatively close. They're shifted by about 12 degrees. And we see that the center of the magnetic field is the center of the Earth. As we look at Jupiter, we see that the spin axis and the magnetic field are only tipped by 10 degrees. But again, the center of the magnetic field is also the center of the planet. For Saturn, the magnetic field and rotation are exactly in line, and the center of the magnetic field is the center of the planet. We do not see these features for Uranus and Neptune. The orientation of the magnetic field and the spin axis rotation are way off. For Uranus, it's 59 degrees off. And for Neptune, it's 47 degrees off. Something serious has gone on. We also see that the center of the magnetic field is not actually the center of the planet. It's shifted off and away from the center of the planet. Something weird is definitely happening with Uranus and Neptune. Our best guess as to what's happening is that Uranus and Neptune might be going through a period of active magnetic reversal. What this means is that the north and south magnetic poles might actually be flipping. And then, so during that time, all sorts of weird magnetic stuff might be happening. We know that the Earth does go through this sort of magnetic reversal everywhere from about 100,000 years to a few million years in scale. Okay, but we do see that it has happened based off of the geologic record. So if both Uranus and Neptune are going through this period of active magnetic reversal, that may explain all of the weirdness that we're seeing. Personally, I don't really like this explanation because the magnetic reversal is relatively short-lived, a few hundred years at most, and why is it that both of them would be going through it at the same time? This seems far too coincidental to me. Now, that being said, maybe it is. Maybe it is just a coincidence. That sort of thing does happen too. there's definitely something weird here that we need to understand better. All right, here's our fourth clicker question. What produces the magnetic fields of Jupiter and Saturn? A. Liquid iron in its core. B. Saltwater oceans deep in the interior. C. Large stores of solid iron and nickel in the cloud layers. Or D. Liquid metallic hydrogen surrounding the core. Go ahead and think about it, and we'll discuss in just a bit. Alright, so the correct answer is D, liquid metallic hydrogen. For any planet to have a magnetic field, it has to have three things. It has to have an electrically conducting liquid in the interior. That area that with the electrically conducting liquid must have convection, and the planet has to rotate fast enough. For the Earth, the conducting liquid is the liquid outer core that is made of liquid iron. For Jupiter and Saturn, it is liquid metallic hydrogen. For Uranus and Neptune, it is a mixture of water, ammonia, and methane that should be a good conductor of electricity. So each of these, all of these, have magnetic fields, but we see that they're being produced from different materials.